evaporation will result in an increase in gas cost, so that we don't consider.
Is evaporation a chemical reaction?
No.
So why are you considering the number of gas particles? Isn't that only going to be used if there is a chemical reaction? You never use number 4 unless it is a chemical reaction. That was what I said. Alright, once you are done, can you look at question number 3? Question number 3 deals with units, and there's a lot of track in question number 3. It looks like a very simple calculation, but there's a lot of track. Okay, so if you don't know what you are looking for, then it's unlikely you will get the question correct. Pay attention very carefully to this question. Once I'm done going through, you will have the time to complete. But pay attention when I'm going through. Okay, look at the question now and tell me which one of these different terms are you given the value in the question. You are given an RV change. But it's very tricky because they didn't give you the correct sign, because they say heat enthalpy is evolved. So when heat is evolved, right, it means that it is an endothermic reaction or exothermic reaction. So can you tell me what should be the delta H value in this question? Negative 44. You need to read the question carefully. Tell me what is the unit? What else do you know about this equation over here that is given in the question? You are given the temperature, but what do I need to do to the temperature? Convert it to Kelvin. I want to convert it to Kelvin. I need to solve for what in the question? To solve for delta S, right? The question never give me the delta G value. Is there something wrong with the question? This one is, actually I don't think it's a very fair question to ask you now, because you're going to learn something called chemical equilibrium in the next topic. But basically you need to know that any phase change reaction is an equilibrium reaction, which means that your delta G should be 0. I repeat, any phase change reaction is an equilibrium reaction. That's why the delta G will be 0. You need to know this. I'll give you an example. Can you tell me what is the boiling point of water? 100 degrees Celsius. What is the condensation point of water vapor? Condensation temperature of water vapor. 100 as well, right? So the temperature at which something is converted from liquid to gas is the same temperature at which the gas is converted back to liquid. So any phase change reaction is always what we call an equilibrium reaction, and that's why the delta G will be a 0 value. But it will make more sense to you after you learn the next topic on chem equilibrium. For now, you just need to know, as long as the question deals with phase change, delta G has a 0 value. Okay? This is not the end of the story. Okay? Can you press your calculator and tell me what is the value of delta S? Don't change anything, keep to the units that is given to you. What is the unit? Positive? 108? Is that correct? I said don't change anything. Use the value that I've given on the whiteboard exactly. Don't change anything. What will be the delta S value? So it's still 118, huh? What if I prove to you it's not 118? I said use exactly what I have written on the whiteboard. Tell me again, what is the value? Plus or minus? Minus what? What? Tell me the units, if it follows exactly the units that I have used in the equation so far. Kilojoules per mole. Kelvin. This is currently the units that I have. I'm just substituting the value as given in the question. Now compare these units with the MCQ over here. What is the first difference you notice? This one is in kilojoules, this one is in? Let's do our first conversion first. How to change from kilojoules to joules? By 1000. Something is still not right if you compare this unit versus these units over here. What is not right? I need to get rid of the mole, right? If I want to get rid of the mole, I need to multiply by mole. So how many moles of water are there in 54 grams? That's why this is your answer. That's why I keep insisting that units are very important. Those of you who are always very poor in your calculation, every single thing you just write your units. You don't want to do it, you get it wrong, then that's your problem. Okay? Because you always do the same thing, and then you keep making the same mistake. So you must always pay attention to the units given to you. I cannot emphasize how important units are whenever you are doing calculation. It's very painful to write the units for every single term, but if you make it a habit to do that for every calculation, I can assure you that your calculation will get better. It's just whether you want to do it or not. Okay? You want to improve things and be painful one. You cannot be always doing the same thing and then expecting different results. Okay, once you are done, look at question number 4. Question number 4 will combine enthalpy change with entropy change at each free energy all together in a single question. Let me write this all on the board first. So there are two equations that we are dealing with for the next question. We'll do it one by one. Okay, so what I want you to do now, right? Can you tell me what kind of data is given to you in the question for number 4? Enthalpy change of formation. So can you see that this is one of the 3 common cycles that you are expected to know? So if you are dealing with enthalpy change of formation, Which one will come first? Reactant come first or product come first? Product come first. So we apply for this reactant first. Pay attention here. Make sure you know how to apply the equation, the formula properly. The overall enthalpy change is already given to you already. So the enthalpy change of this reaction is the formation of this product minus the formation of this reactant. How many NO2 are you forming? Each one of these has what value?
Plus 3.
Plus. Better tell me properly.
33.0.
How many NO3 are you forming? Each one of them has what enthalpy change or formation? Do you know?
No.
This is what you want to find, is it? Okay, then let me use a symbol to represent that. Okay, so this is your product. Then minus the reactant. How many N2O5 are you forming here? Tell me each one of them has what value? Plus or minus? So this is your reactant. Can you see that the only thing that you don't know is this one? Okay, then you should be able to tell me your value already. Tell me what is the value for this one?
64.3.
You please tell me it's plus or minus.
Plus
Plus what?
64.3.
64.3. Okay? Kilojoules per mole, okay? Then now you can apply this value to this equation over here to find the enthalpy change of the second reaction. Again, you're going to apply this formula. So it's the formation of a product. Now you are forming 2 NO2, so please be careful. Each one of the NO2 is 33.2. How come this value is not given to me, the formation of O2? It's in the data booklet. I'm not saying it's in the data booklet. I'm saying you told me that it's in the data booklet. Why is the enthalpy change of formation of O2 not given?
Because it is 100. Because it's minus. Because it's 0.
I'll try to do it right on the board. What does it mean by enthalpy change of formation of O2? Just another color. Write the equation that represents the enthalpy change of formation of oxygen gas. Do you understand English? So tell the O class why the question didn't give you the enthalpy change of formation of O2. So
there's no change in energy.
So what is the enthalpy change of formation of O2?
0.
What is so difficult about this one? We said before the enthalpy change of formation of any element is always 0 1. You don't need energy to form an element because it is really an element to begin with already. How many NO3 are you forming? Each one of it is one value. This is what you have calculated over there. Tell me me what is the value for the second reaction. Plus, minus
62.2.
point.
2.
Okay, so this one actually is just division for enthalpy change. There's nothing new here. So just quickly check the answer before we move on to the next part, which is what we should be focusing on for this particular chapter of delta G. Of course, there is no need for you to write the formula in exam. I'm just showing those of you who don't know that you can apply this formula, and you can actually do so over here because you are dealing with enthalpy change of formation. Most common mistake in exam is forgetting your coefficient. So those of you who never multiply by 2 in front of the NO2 and NO3, that means your answer wrong already because you never account for the coefficient in the different species that are given to you. Okay, let's move on now to the next question. The next part of the question. Okay, I just want to just say first, in your exam, every time you see the word spontaneous, right? Confirm it must be this formula one, delta G equals to delta H minus T delta S. So you just see the word spontaneous, you just straight away write down this formula because confirm it has something to do with delta G one. There's only one formula that relates to spontaneity of the reaction. So now they are asking you whether reaction number 1 or reaction number 2 is more spontaneous. Pay attention first. This is how you should be analyzing the data. We start with reaction number 1 first. Tell me the delta H of reaction number 1. Is it a positive value or negative value? We also need to know the sign of the delta S. It's just qualitative only. Is this a chemical reaction? So we should be considering which factor when we want to know the sign of delta S. What do you notice about the number of gaseous particles? So do you expect the delta S to be positive or negative for this reaction? Whenever you do this kind of question, they ask you about the spontaneity of the reaction. You always need to consider two scenarios. One is at low temperature, the other one is at high temperature. Look at how I present my answer. This is the part due to bond forming and bond breaking. This is the part due to the rearrangement of particles. When the temperature is very low, which one of these two parts will dominate? The first part or the second part? And this is how you write it. What does the vertical line mean? What does the vertical line mean? Magnitude. So this is the way you write it because we are only interested in the magnitude over here. So at low temperature, this is the part that dominates. What about high temperature? Which one will dominate? Second part. Then you want like this. When the delta H dominates, can you tell me what will be the sign of delta G since this one is a positive value? When this is the part that dominates, can you tell me what will be the sign of the delta G since your delta S is a positive value? If you want the reaction to be spontaneous, the delta G needs to be positive or negative? Negative. So this reaction is only spontaneous at high temperature. Now we do the same thing over here. For the second reaction, delta H is plus or minus? Minus. Look at your delta F. This is a chemical reaction, so we should be using number 4. What happens to the number of gaseous particles? So what will be the sign of delta S? Plus. Do the same thing. The same analysis. Low temperature, this one will dominate. High temperature, this one will dominate. So for this case, when your delta H dominates, what will be the sign of delta G? When this is the part that dominates, what will happen to the sign of the delta G? So for reaction number 2, it is spontaneous at all temperatures. Which reaction is more spontaneous? Second one. This is how you do this kind of question. You need to provide an explanation of why the delta S is positive for both reactions. And basically, it involves an increase in the number of gaseous particles. Like I said, this topic is not a very big topic. Okay, it's just a very small topic only. So there are only a few concepts that you need to be familiar with. Once you know the concept, the questions are very repetitive. If you need to record a lesson, you need to inform the teacher. To be respectful. Okay, you won't just record without letting the teacher know. Okay, make sure you always use the modular sign because we are only interested in the magnitude. Whether you want to put the negative sign in front of the T delta S, it doesn't matter because we are only interested in the magnitude, so it doesn't make a difference. So this we have one more question to go, and the last question is actually very similar to question number 4. We are doing exactly the same analysis once again. Okay, once you are done with question number 5, then we finish the tutorial for OP today. Next week we can start on reaction kinetics. Okay, those of you who are fast read the last question. In your exam, this one you can just write it one time. You just say that for reaction 1 and 2, there's an increase in the number of gas particles because this thing is repeated. So you don't need to write twice the same thing, the same words. Okay, so actually this one you can just write it once. Just say the same thing happens for both reactions. So therefore, delta S will be positive for both reaction 1 and 2. So don't need to write the same thing twice. You need to know how to save time in exam. Your review test is not considered to be something that you should be struggling with time. So if you did struggle with time, you need to make sure you work on your time management as well. Knowing how to do the question is not the same as being able to do the questions within the allocated time. There are different skill sets. Okay, 30 more seconds, then we will move on. Those of you who are done or waiting for the rest of your classmates to actually finish copying, can you please read the graph and then get all the delta T value and the different temperatures so that when I ask you, you can tell me. I mean, it's not going to be very accurate because the graph given to you, it's also not very clear, but never mind, just write it to the best of your ability. What is the delta T value at different temperatures? Okay, do it now, or waiting for your classmates to be done. Roughly, just estimate. Okay, I know it's not very accurate. Okay, let's do this one first. For reaction number 1, at 500 Kelvin, what is your delta T value? Roughly? Minus? Okay, then what about your reaction number 2 at 500 Kelvin? 500 Kelvin reaction number 2. Huh? 310, okay. What about 2000 Kelvin reaction number 1? Minus? Okay. Reaction number 2, 2000 Kelvin. Okay. Now you can tell me already, at the lower temperature, right, which one of the two reactions is more spontaneous? First one or second one? First one. For the 2000 Kelvin, which one of the two reactions is more spontaneous? That's basically how you do the first part. Cannot be too difficult one. Anyway, they are asking for reducing agent. Reducing agent undergoes oxidation. Alright, so basically they are just asking you which one of the two reactions undergoes oxidation more spontaneously. That's what they are asking you. Because those are both oxidation processes because you are adding oxygen. So they are just asking you whether reaction 1 or 2 takes place more spontaneously at a different temperature. That's what they are asking you for the first part of the question. Ignore the reversible arrow for now. Okay, I don't know why they place it in this tutorial when you haven't covered chemical equilibrium. So just ignore the reversible arrow for now. It will make more sense to you after the next topic on chem equilibrium. Shouldn't be too difficult, this one should be pretty straightforward. Quickly, 5 more minutes, I want to finish the tutorial, I don't want to just leave one part hanging. Okay, let's move on now. Okay, anyway, for this part, right, they are just asking you how does the delta G get affected by temperature. Can you tell me which half of the delta G formula is affected by temperature? The first half or the second half? So we only need to focus on the second half only. But in order to focus on the second half, we need to know the sign of delta S first. Look at the first reaction. What should be our focus on? The number of what particles? So is there any difference in the number of gaseous particles? So you expect delta S to be approximately 0 because the number of gaseous particles is about the same. Now look at the second reaction. What happens to the number of gaseous particles? Increases. So do you expect delta S to be positive or negative? So now you should be able to answer the question already. How come reaction number 2 becomes more negative as temperature increases? Because as temperature increases, this part becomes more significant, right? That's why your delta G becomes more negative. And how come for reaction number 1 is independent of temperature? Because delta S is not 0. It's about 0. It's not equal to 0. That's the difference. So there must always be a part where you need to explain what is the sign of the delta S first. You don't just say delta S is plus, minus, or 0. You must explain why. Okay, why is it plus? Why is it minus? Or why is it 0? Then only you start explaining. Okay, the last part of the question is super important because you get this question very often in exam. Many of you will be wondering how to find the delta S if the person never even give you the delta H value. Okay, it's actually math, but it's more math than chemistry. Okay, now look here. Give me 2 more minutes. I want to solve this one. So now they ask you to find the delta S, but the question didn't even give you the delta H. How to solve for the delta S? Like I said, it's just mathematics. Go back to the graph. Okay, now look here. Is this the same as this? I just rearrange everything, but they refer to the same thing. Tell me what is your y-axis? Tell me what is your x-axis? So what is this? What is this? So basically, how to find delta s? Gradient is not your delta s. Gradient is minus delta s. So after you found your gradient already, you need to put a minus sign over there. I can also ask you to estimate your delta h. Therefore, you just need to read the y-intercept. It's just math only. Finally, if you find the gradient, tell me what is the unit of delta s? Gradient. So that is the unit of the gradient, it's y over x. Okay, this is math, nothing to do with chemistry. Right? Yeah? Yeah, you can solve simultaneous equation as well, no problem. You just find the data at 2 points, then you solve simultaneously also can. Yeah, so we are done with this already. Okay, so entropy is done already. Next week, we will start on kinetics proper. We are only left with 3 weeks. To the end of the term, we have 2 more topics. The decision of the department is the last topic on chem equilibrium is a self-study topic. That is not my decision. Okay, so anything you not happy, okay, ask your parents to complain against the school, not my problem. Okay, so that is chem equilibrium, decision of the school self-study. So the last topic I will go through with you is kinetics. Yeah, done already. Whoever needs to meet me now. Otherwise, you can go for your break already. When were you supposed to submit? When were you supposed to submit? When were you supposed to submit? What do you mean by when I message you that you're supposed to read that? Then you say that you're back to school, you are doing the meetings on the
Bye, Seth.